All right. Today we're doing learning target 10 and 11. So we're going to talk about the amplitude and period of sine and cosine functions. So we're going to start kind of shifting sine and cosine around and doing some things to it. So that's why you have to be able to graph sine and cosine. That's why we spent so much time making sure you could do learning target 9 last week. So amplitude will be easy, but then period, we already talked about that at the top and repeat. Last week we didn't do anything to that. Well, today we're going to be changing it. So we're going to be stretching and compressing. So you're going to need to be able to do the original graph in order to stretch it or compress it. So first thing, some definitions. The amplitude will be easy. The amplitude is just the height of the function. So last week for sine and cosine, the maximum was 1 and the minimum was -1. If we change the amplitude, we're just changing the maximum and minimum values. So that's going to be a vertical stretch or compression, because we're making it taller or more squat. We're going to be doing pulling it upwards or smushing it down. So in your function, A represents the amplitude. And so you can see that A is being multiplied by sine or cosine. It's out there in the front. So it's going to be easy to identify and pick out. And when I ask you for the amplitude, remember that the amplitude will always be the absolute value of whatever's in the front. So the amplitude is not going to be negative. The amplitude will be positive. Any questions about that? We'll actually do an example in a second. Amplitude is talking about height. All right. The period we've already talked about a little bit. The period is still how often a function repeats. So for sine and cosine last week, the period was 2 pi. Right? That was one rotation around the unit circle. And if we kept going, we'd have repeated the wave, right? We're going to be changing that today. So in your equations, you have some number, some value in front of theta. That number is not the period. So K is not the period. So if it says y equals cosine of 2 theta, the period is not 2. Okay? The period is 2 pi divided by that number. All right, so I've got one example of this. This is learning target 10. Just be able to pick it out. We're not graphing or doing anything. We're just looking at the equation and writing on what the amplitude is and what the period is. So for the first equation, y equals 1/2 times the sine of 4 theta. What is the amplitude? 1/2. Not an issue. That's easy to pick out. How am I going to figure out the period? We're just going to 2 pi divided by 4. Right? It's just the number in front of the theta. So 2 pi over 4, what does that reduce down to? Pi over 2. So the period is pi over 2. Any questions about how I found the amplitude or the period from the function? No? Maybe, yes, no? All right. So if you can do that, you can learn target 10. That's not bad. For learning target 11, there's 2 parts. Learning target 11, you should be able to write an equation for a sine or cosine function if they say, hey, here's the amplitude and here's the period. You should be able to write the equation. We should also be able to graph an equation if they give it to us. All right? We're going to write equations first because that's easier, and then we'll get into the graphing part. And we'll take more time to do that. So we're going to do the writing part of equations for learning target 11 first. All right. So the first 2 examples, we're writing equations for the sine function The other two examples writing for cosine, it doesn't matter though because they work the same way. It's just whether you're writing sine or cosine in the equation. That's all that changes. Okay? So if you look at the first one, it says the amplitude is 0.8 and the period is pi. So right now, if I was going to write the equation, I should be able to write this much of it. So should you. Y equals 0.8 sine of something theta. You know that much to write in the equation. Because we already knew the amplitude was going to be there in the front. I know the period is pi, but that's not what goes in the equation, right? The k goes into the equation, and k is not pi. Everyone with me on that? So I need to figure out what k is to finish this out. So again, we have the equation period equals 2 pi over k. Right? Well, the period is pi, so I'm just going to substitute that in. And then we're going to cross multiply to solve for k. So pi times k equals 2 pi. So I bet you can figure out what that is, but if not, you can divide by pi. So k equals 2. So the equation is y equals 0.8 times the sine of 2 theta. Does that make sense? Yes? I'm going to do one more of these, and then we'll let you do two. I'm going to skip down here to the very bottom to the last example. This one's cosine, but that doesn't change anything. You just write cosine instead of sine. Again, you should be able to write, right now, you have enough information to say y equals 3/4 times cosine of something theta. We know the period is 6, but that is not k. So to figure out what k is. This one is. It's the very bottom one in the corner. So we've got 6 equals 2 pi over k. Right? We can cross multiply. 6k equals 2 pi. We're solving for k. So we get 2 pi over 6, which reduces down to pi over 3. And so sometimes you'll have a pi still left over. That's okay. Questions about how I did that? All right, then. You are going to do the other two examples then. Do the other sine equation, do the other cosine equation. I'll give you a few minutes, and then we'll make sure that you did them correctly. Okay. On the sine curve, this one right here, we have 2 to 7 period of pi over 3. You should have y equals 7 times the sine of 6 theta. So I need to go over how I got that. Any questions on that one? Okay. Then on the other cosine curve, amplitude of 1.5 and period of 5 pi, you should have y equals 1.5 cosine of 2/5 theta. Any questions about that one? I'm assuming the period part, right? Because the amplitude part we got. 5 pi equals 2 pi over k. So when you divide by 5 pi, the pi's cancel it. That's okay. You figured out your mistake. You're good. All right. Any questions on those? Could you do those on your own? They're all the same, right? You just keep doing the period equals 2 pi over k and solving for k. All right. So then the hard part of this whole entire day is graphing. And I'm going to make it as easy as possible. All right. But it's going to be your responsibility. You have to start thinking in some ways that I'm going to tell you to think, all right, to make your life easier. Today we're just doing amplitude, which is vertical stretches and compressions, and period, which is horizontal stretches and compressions. So it's not that big of a deal. But after your quiz on Friday, the next learning targets, we start shifting things. We start doing vertical shifts and horizontal shifts. And so if you can start thinking how I'm thinking, then this will make your graphing like exponentially easier. Okay? So if we're going to graph, first of all, before I do any examples, I just want to remind you of what the sine curve and the cosine curve look like from last week. Okay? So we graphed the maximum values and the minimum values and the x-intercepts for both of these, right? We'll make this one sine. For sine, we started at 0, 0, and then it went to the maximum value, and then it went back to the x-intercept, and down, and so it looked like this, from 0 to 2 pi, right? For cosine had the same maximum minimum value, but it was a little bit shifted from where sine was. So cosine started at its maximum at 0. And looks like this. Now, we were graphing intervals in Learning Target 9. They didn't necessarily look like this because we were graphing different pieces of the wave. All right? In this case, when we are doing horizontal stretches and compressions, the shapes are always going to make these two shapes every single time, right? We're going to do one full period starting at 0, okay? So it's always going to look this exact same way. We're just going to squish it together, stretch it out, right? So the sine curve goes up and then back through the x-axis and down to the minimum and back up, right? Cosine makes a nice little U shape, right? Those are the cross sections of the, I could keep going so it really makes a wave, right? Those are the cross sections of one full period. That's what they look like, right? If you can think that way and you can kind of picture what it looks like, and you know that for sine, you start at 0, 0, and then go up, and then down, down, up, and make the pattern, then you'll be able to graph these really easily, okay? So if you start thinking about what those pictures are, what those shapes they make, this will be easier. Because on your homework, theoretically, every single sine curve that you graph should look practically identical after I teach you how to do this. It'll be different each time, okay? And every cosine curve you graph should look pretty identical, except the scale is going to be different. All right? So, for this first example, I'm going to leave those two down there for reference. Y is 10 times the sine of theta. What's the amplitude? 10. The amplitude is 10. So that means my maximum value is going to be at 10, and my minimum value is going to be at negative 10. That's all that. So we're stretching it out vertically. No big deal. What's the period going to be? K is 2. What's the period going to be? Well, the period is always 2 pi divided by K. This is K, right? So you have 2 pi divided by 2, so pi. Right, the period's pi. Everyone know how I got that? Now, I'm going to scroll down again for a second. I'll scroll back up. For sine, one full period goes from 0 to 2 pi. But now we're changing the period to pi, right? That means that I am going to be squishing this entire curve into from 0 to where that dotted line is, right? I'm squishing it. Squishing it together, right? It's going to have to be that full curve. So it would be nice to know where the maximum and minimum values and all of those x-intercepts are going to occur, right? So I don't have to like guess at it and like have random points, okay? So here's my advice to you. You don't have to take my advice, but if you don't, you're going to be struggling. Once you have the period, right? If you notice on this graph down here, there are 4 distinct points after 0 where there's a maximum, minimum, or an x-intercept, right? So if you take the period and divide by 4 each time, every single time, you will always get the hash marks or the scale for the new graph. That will include the maximum, minimums, and x-intercepts every time. Like I'm guaranteeing you to be successful. Okay? So right now our period is pi. And so if I divide that by 4, then I'm going to be using pi over 4 as my new scale. Does that make sense? I'm just dividing it by 4. So instead of going from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi, we're just going to be counting by pi over 4. So I go from 0, pi over 4. What is 1 pi over 4 plus 1 pi over 4? Which reduces down to 2 pi over 4 reduces down to pi over 2. But we had 2 pi over 4, so plus another pi over 4 would be what? 3 pi over 4, right? 2 pi over 4 plus 1 pi over 4 would be 3 pi over 4. Plus another pi over 4 would be what? Pi, or 4 pi over 4, right? And that's what we want to graph. We want to graph one full period, so from 0 to pi. Got it. Okay? Now you have two options. All right? You have the long way, which may suit you for a little bit as you get used to this. And then you have the short math teacher way. So we'll start with the long way. The long way is the never fail how to graph a function, make a t-chart. Right? You can put x values in, you get a y value out, right? So in this case, we're not using x's, we're using thetas. Same concept, though. So, and here are my 4 values I'm using. So pi over 4, pi over 2, 3 pi over 4, and pi. And I can substitute those into this function. So I could do 10 times the sine of 2 times pi over 4. What is 2 times pi over 4 is pi over 4. And we already decided 2 pi over 4 reduces down to pi over 2. Then you could use your unit circle. And the sine of pi over 2 is 1. And 10 times 1 is 10. So there must be a point at pi over 4, 10. And you could do that again. Pi over 2. 2 times pi over 2 is 2 pi over 2, which is just pi. And the sine of pi is 0, using your unit circle. And 10 times 0 is 0. So there must be a point at pi over 2, 0. And we can keep going, and you get negative 10 and 0. Just started at 0. Yep, unless you're doing horizontal or vertical shifts, which you're not doing right now, so yes. So if you look at our graph of just y equals sine theta, again, they should look identical, right? The shape is the same. We've just changed the scale, right? Instead of going from 0 to 2 pi, we're going from 0 to pi, right? But this general shape is the same. So that was the long way. You can make a t-chart. The short way, math teacher way, how I will always be doing them so quickly, how you could do them so quickly too, is that you know the shape. I know that it starts at 0, 0, and we go maximum, 0, minimum, 0. So I've already changed the scale. I know I'm counting by pi over 4, so I've got the scale right. So I know what it's going to look like. Bam, 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 bam. Don't have to make a t-chart. Okay? This is what the sine curve looks like down here. Right? If I squish it, yeah, if I squish it, it's still going to look the same.
Right. Oh, that's easy.
Yeah, math teacher. The genius way.
Why does everybody do that?
They should. I'm telling you, you're going to save yourself immense amounts of time. If you're trying to do this t-chart still, when we get into learning target 12 and 13, you will be doing your homework for hours. Because once we get to 12 and 13, we're going to be doing amplitude changes and period changes and vertical shifts and horizontal shifts. That's a lot of things to do. No, that's not taught for the quiz.
Well,
Yes.
so we're done.
Right. So we're going to take a break. We'll get there. We're going to work on some things with this learning target. We're going to review a little bit this week, right? But after, I mean, if you're going to be doing a T-chart all the time, we're just going to be taking lots of time, right? Is everyone okay with how I did that first example? Yes, everyone okay with that idea? Mm-hmm. No, that's just one way to do it. All right. Any other questions about that first example? I'm going to do another example, so no worries. But we good? All right. Let's look at. I'm going to skip one. I'm going to do this one next. I'm going to do the sine of 0.5 sine of theta over 6. Because it's sines, we just do one like sines. You can see how this is working. All right. What's the amplitude? 0.5. That just means that when I label this, I'm going to have a half and negative 1/2. So I'm squishing it vertically, right? Making it shorter. How am I going to find the period? False. No, I didn't. How am I going to find the period? Two pi over k, and k in this case is what? Theta is a variable, so it would just be 1 over 6. Right? K is the number multiplied by theta, so it's 1 over 6. So 2 pi divided by 1/6, that's the same thing as multiplying by 6, right? When you divide fractions, you multiply by the reciprocal. So what's 2 pi times 6? 12 pi. All right, so we know that we're like really stretching this one out, right? Instead of going from 0 to 2 pi, we're going from 0 to 12 pi. It's going to be like way stretched out. Now on your homework, it's look the exact same. It's going to look identical to the last one we did. We're just changing the scale, but if you drew in the original sine curve, you would definitely tell a difference. So what was my next suggestion after I said define the period? What should I do? Right, so divide the period by 4 so I know what the new scale is going to be, right? So what's 12 pi divided by 4?
3 pi.
3 pi. So that is what I'm counting by. So I'm going to start with 3 pi. And 3 pi plus 3 pi is 6 pi. Plus another 3 pi is 9 pi. Plus another 3 pi is 12 pi. See how that makes that so nice? Now again, you could make a T-chart. And you could substitute all of those in. And you could use your unit circle. And you could figure out what the points are. Or you could do it the quick way. We know what sine is supposed to look like. It's supposed to start at 0, 0. And this is to go to the maximum. And then back down, right? So here, that's what I'm going to do. Starts at 0, goes to the maximum, which is a half. Back to 0, to the minimum, back to 0. Questions about how I did that? And we're just thinking about that pattern. Now again, just for reference, you don't have to draw this in. But for reference, the original sine curve is this right here in the blue. So we have definitely stretched it out, right? We've way stretched it out. But on your homework, it's not going to really look necessarily like we stretched it out because we just changed the scale on our graph, right? I just want you to understand that you are changing what it looks like each time. Any questions on that one? All right. I'm going to have you do this first cosine curve by yourself. Y equals 3 cosine 2. I want you to try it out because I want you to see how you're doing. Here is cosine, the original cosine for reference. All right? In the event that you want to, use the short method of doing things. Okay? But I want you to do that one. Don't do both of them. Don't do them with a negative in front. We'll talk about that one in a second. But I'm going to be around to make. All right. If you did this one correctly, you should have a maximum of 3 and a minimum of -3. Your period should have been pi. You should have pi over 4, pi over 2, 3 pi over 4, pi. And it should look like that. Yeah? Question? It's just 2 pi divided by 2. K, which is 2. Uh-huh. So you'd have 3 times the cosine of 2 times pi over 4. 2 times pi over 4 is pi over 2. Cosine of pi over 2 is 0. And 3 times 0 is 0. Make sure your calculator's in radian mode. We're using radian measures, so you should be in radian mode. If you're in degree mode, then it's reading that pi over 4 as a degree measure. All right, any questions on that one? All right, on this last one, I just want to do it really quickly together because it's got a negative in the front and that actually matters. Now, first of all, if I ask for the amplitude, what are you going to say? 1/5. Do not say a -1/5 because you would be wrong. Remember, our amplitude is the absolute value. I guarantee you, I'm telling you right now, so it's not even mean. I'm telling you, on the quiz, when it says, what's the amplitude in the period, just someone's you're naming it, I guarantee I give you one with a negative in the front. And someone's going to write down the negative on the quiz answers, and it's going to be wrong because the amplitude is always the absolute value, whatever it is. So don't put the negative. How am I going to find the period? 2 pi over a 4th, which is 8 pi. Yeah, maybe. Okay. If I'm going to try and find the new scale, 8 pi divided by 4 is 2 pi, right? So I'm counting by 2 pi. -1/5. -1/5. Now here's the problem. Let's say this was just positive 1/5. Don't draw this, but it's not. If it was positive 1/5, we do just like we did before with cosine, right? We go here and here. Getting so good at this. Right? That's what it would look like. But it says negative. So if it has a negative in the front, that is just a reflection over the x-axis. So it's just upside down. So instead of starting at the top, we start at the bottom. Got it? Yeah? Question? Now listen very carefully to my instructions. You have 5 minutes left of class, but that doesn't matter because tomorrow in class, you're doing Learning Target 10 and 11 homework. That way you don't confuse yourself trying to graph these at home. So you don't have homework because you're doing it in class tomorrow.